Okay, question 6 is your integration by substitution question. There's a little technique that you'll see here that I use just to make things a little bit easier, just to cause you a bit less stress when you're working through these sometimes tricky questions. We always start off by writing on the right hand side, well I do, on the right hand side what the substitution is, and then differentiating that equation. So that's just going to give us 2, and then saying what dx will equal. So in this case, dx is going to equal du over 2, or a half du, you might write. You can obviously see here that that's going to be our u, but the top isn't obvious what we're going to write down. What we can do, which is a little bit not sneaky, it's just quite a nice little bit of manipulation that we can use. We can say that 2x is going to equal u take away 1. Because what we're going to want to do is write what 4x minus 1 is in terms of u. So I can now double this to get what 4x is equal to. And if I want 4x take away 1, I'm just going to take away 1 from both sides. So the top, the numerator here, is going to be equivalent to 2u take away 3. And doing this, it just avoids the fraction element of it. It would have been even nicer if that had been a 2x, not a 4x, but it was nice that it was at least a multiple of it to avoid the fractions. If that had been a 5x, we wouldn't have been able to avoid fractions. But it just saves a little bit of effort, I think. So what we can now do over here is write 2u minus 3 over u to the power of 5 times du over 2. I'm going to take that over 2 out of the integral because it's a constant. It just makes things a little bit easier. And the next thing I'm going to do is split those two fractions up. We can tidy that up, we can simplify those two fractions. We're going to want to bring the powers up as a negative as well, so that's going to simplify to over u to the 4, so I'm going to write that as 2u to the minus 4, and this is obviously 3u to the minus 5. We're now in a position to integrate it. Add 1 to the power, divide by the new power. That's going to become a plus 3u to the minus 4 over 4. We need to sort out our limits for the u's so that I don't have to put x back in. I could put x back in, but I'm just going to change the limits instead. We've got that we need to know when x is a half, what u is equal to. And we can see that here, when x is a half, that's going to be 1, so u is going to be 2. And when x is 0, u is going to be 1. So my new limits are 2 and 1. So we're now in a position to put those numbers in. You might find it useful to put that u back underneath. It's up to you. I tend to do it. Sorry, I've lost a minus there. We're dividing by minus 3. So, half stays outside. Minus 2 over 24 plus 3 over 1664 minus 2 over 3 plus 3 over 4 is going to be a half of, let's get my calculator, minus 2 over 24 plus 3 over 64 is minus 7 over 192 minus 2 over 3 plus 3 over 4 is a 12th, so then we're taking off a 12th. So minus 7 over 192 minus 1 over 12 divided by 2 is minus 23 over 384. Seems a bit of an unusual answer, a negative answer, and if you're worried about getting an answer that seems weird or wrong, then if you have one of the new calculators, if you've got a Class Whiz or an FX991, then you can use it to actually check your integrations. There's an integral button on your calculator, and you can type that in exactly how it looks in the question to get an answer, and if you do check it, this is right. We've got the right answer there. So don't worry that it's negative. It's good to check your answers in your exam anyway, so I would suggest that you, as soon as you finish an integration question where you're putting limits in, then I suggest you use your calculator to check that you've got the right answer, but only after you've finished the question. Don't try and use it during the question, otherwise you might be tempted to not show you're working out properly and not pick up all the